One last thing I want to talk about in the world of vector math is subtraction. Most of the time we're going to be doing addition of vectors, but once in a while subtraction will come up. So how do we do subtraction? I'm just going to kind of illustrate this using an example because it's very similar to vector addition. So I have an example up on the screen now. We have two velocity vectors that are described in words there, and we want to calculate the difference, A minus B. So how do we do that? So as usual, first thing we want to do right off the top is draw the two vectors before we even think about attempting to solve anything. So let me start out by drawing these two guys. So let me maybe draw a coordinate system here. We've got vector A is 10 meters per second, 40 degrees south of west. So that's going to be something like this, with the 40 degrees being south of west. So that would be 40. There's vector A. And the other vector is 20 meters per second, so twice as long, and 10 degrees east of north. Let's use a different color for this guy. So just a little bit east of north, but much longer than vector A. So maybe something like this. Okay, and that angle there is 10, and this is vector B. Okay, so how do we do A minus B? Let me explain it geometrically first, and then I'll explain how you do it with the component-based method as well. So geometrically, there's a few different ways to think about it, actually. Let me show you my favorite method. If you look up in other sources, you'll find some other methods as well, which will result in the same answer. But the way that makes the most sense to me, since I understand vector addition, why don't we cast this basically as a vector addition problem? So one way to do that is I have C equals A minus B here. Just like with variables, if C equals A minus B, that's the same thing as C equals A plus the negative of B. So if I can find negative B vector, then all I have to do is an addition problem from that point onwards. So let me explain, what is a negative vector? How do you make a vector negative? And the answer is, to make a vector negative, let me actually write this down because this will be semi-important. So to make a vector negative, it has the same magnitude but opposite direction. So you leave the length of the vector alone and basically just flip it around so that the arrow is on the other side of the vector. Or in component form, you make both components, or I should say you change the sign of both components of that vector, and that will make the vector negative as well. So I have vector B shown there. So what would vector negative B look like? So the answer is, we want a vector that's exactly the same length, but has the arrow on the other side of the vector. So vector negative B would be like this, with a 10-degree angle here. So that's vector negative B. And that also has length 20 meters per second. Okay, now, if you're good with that, then all we have to do is add vector A plus vector negative B, which we already know how to do. So one way to do that, let me just make a copy of vector negative B there. Okay, so one way to do that, as I explained in previous video, put vector negative B at the end of vector A. So I'm anticipating that vector A minus B should be something like the pink one there. So the pink one is my geometrical estimate of what vector C is going to look like, because it's vector A added to vector negative B. There's a number of other ways you can do this. Another very simple method of doing this, if you kind of prefer algebra, we have up here, we know that C equals A minus B. So another way to think about it is add B to both sides of the equation. You are still allowed to do that with vectors. That would tell you that B plus C equals A. Once again, we've recast this as a vector addition problem. And you'll notice that this still works out as well. Let me draw that for you, what that would look like. Let me just make copies of these vectors. So here's vector B in blue. And let's get vector A in red. So the way you could do this is start vector B and vector A from a common origin. And then ask yourself, okay, if I wanted to do B plus C equals A, you would start C from the end of B, and it should end up here at the end of A. And you see we get the same vector C that I got earlier. The two pink vectors are identical, arrived at in two different methods. And there's some other ways you can do geometrical vector subtraction as well, but they all lead to the same basic final result. Okay, so that's how you can wrap your head around subtraction geometrically and visually. The other question is, more importantly, how do you deal with vector subtraction in terms of components? And really it all comes down to this statement here, that if you want to make a vector negative, you just make both of its components negative. So as a result, it works exactly the same way as vector addition, where you separate out the components from each other. And once you get the X and Y components separate, you can just subtract them from each other, just as you would normally. So let me show you that. Let me make a little bit of space for myself. Let's get rid of some of this. Okay, we can get rid of that too. Oops, did not want to get rid of that. All right, let's leave it like that. So how do we do component-based stuff then? Let me clean this up. I'm not going to need vector negative B anymore. I could do it with vector negative B, but okay. So first thing I want to do is get the X and Y components of vector A and vector B. So let's do that. For vector A, the X component is negative, first of all. The magnitude of vector A is 10. And now, is it sine or cosine? I'm visualizing a triangle that looks like that. And the X component is this side. So that means the X component is adjacent to the 40-degree angle. So I'll have cosine 40. And what happened to my calculator? Well, I'll just keep going. So we've got vector AX there. We also need AY. So AY is also negative. It'll be 10 meters per second. Sine of 40. Now we break B into its components. BX is positive because it's pointing to the right. And for B, I'm visualizing a right triangle like that. BX is up here. So I can see BX is opposite of the 10-degree angle. So this is going to be positive 20 times sine of 10. BY is also positive because it's pointing upward. And this is going to be positive 20 cosine of 10. Then once you got those components, all you do now is CX equals ax minus bx. So you can just subtract the components, and that's all there is to it. If bx is negative, it'll end up becoming an addition because you're subtracting a negative. But you just algebraically do a subtraction of the two numbers. And likewise for the y component here. And I'm not going to crunch the numbers on this because I don't know what happened to my calculator. But this is the basic idea of how you, actually, I guess I could just bring up the on-screen calculator. Just takes slightly longer. So 40 cosine. So this guy is going to be negative 7.7. Bx is sine of 10 times 20. And I got for that 3.5. So Cx is going to be negative 7.7 minus 3.5, which is negative, what is that, 11.2, if I'm doing my mental math correct. And then likewise down here, you do the same basic idea. I guess I might as well do it, because in these videos, you can always, if you don't like seeing all the details, you can always skip it yourself. 6.4, the negative in front of it. And this one here, cosine of 10 times 20. That gives me 19.7. So then this would end up being negative 6.4 minus 19.7 is 6.4 plus 19.7 equals 26.1. Okay, and you'll notice conceptually, it is in fact pointing down and left, which is what I was expecting from the geometrical answer. So it seems to be in the right ballpark as my picture. And then finally, depending on what question was being asked, those are the components of vector C. If you wanted to know the magnitude and direction of vector C, you would just do Pythagorean theorem on that. Magnitude of C is square root of cx squared plus cy squared. And if you want to know the angle of vector C, you would just turn it into a right triangle, say maybe this one, solve for this angle here, and then convert it into the language of wherever you wanted to measure that angle from, as we talked about in previous videos.